Alright, so graphing parabolas. We'll also graph absolute value functions today. Okay, we're going to start with y equals x squared, because that is the parent graph. So parent graph is like the most simple equation that you can make of a certain family. So I can't think of an easier parabola than y equals x squared. So all of our graphs that we'll make all have transformed the parent, y equals x squared. We might make it skinnier, we might make it wider, we might shift it up or down or left and right, we might flip it upside down, but it's all based off of the parent graph and the transformations of that parent graph. So if you have questions about your calculator, it's important to get those. I want you to be able to use your calculator for lots and lots of things in here. So if you're having questions, which you should because most of you haven't had much experience with it, just ask and I can help you on almost every. Teach long enough, you learn pretty much everything on the calculator. Alright, so we're going to go to, if you have to clear, you can hit clear right here. If you have stuff on your screen, you hit clear. And people at home, virtuals, I know that there is an app on your phone if you have an iPhone or a smartphone, and maybe that's what you want to do. Some students do that. I think there's an app that this calculator does. I know there's some things that it doesn't do. I think it's enough though that that might be enough to replace your calculator. So if you want to find a graphing calculator app, probably looking for a TI-84 or something like that, and that's the one I have here. There is an app that allows you to just use your phone as a calculator. It's actually a pretty good, it's like the same buttons and everything. Okay, so we're going to graph. The first thing we want to do is y equals, which is in the upper left hand corner. You can hit y equals, and you can type in any equation you want to, and it's going to graph it. The X button is right next to this alpha button right here. It's got X, it's got T, it's got theta, it's got N. So that all depends on what mode your calculator is in. We are not going to change the mode in this class, so it's always going to be X right there. Once you get into pre-calc, you'll change the mode. We changed the mode in Calc 1 and Calc 2, but for our purposes in algebra, it's always going to be in function mode, so we can just use, that'll always be an X. And there is a squared button right here. Right here, it squares it, so we just hit squared. If we wanted to do x to the third, we would do x, and then this is called the caret button. That's the caret key, kind of because it's supposed to, like, that would be a caret if it was skinnier, like that, but it's not a skinny one, but it's still called the caret b. So that means to the power right here. So x to the power of, and then we could do x to the fifth if we wanted to. But we don't want to, we want x to the second. Alright, so now we're going to graph it, y equals x squared, and graph is in the upper right corner right here. I'm going to hit graph, and a lot of your calculators are going to have the same thing as what I just did on the screen. Some of you might be different because your window might be adjusted. If you're ever messed up, maybe it says dimension mismatch, or maybe it's way zoomed in or way zoomed out, you can always do this zoom. Get used to doing zoom standard, which is zoom 6. Zoom standard will give you the regular snapshot of, like, it's centered right at the origin, and it's zoomed out just the right amount. So zoom standard is a good place to always start your graph. So we have y equals x squared. That is the parent function. Okay, so virtuals, are you just following along, or are you using Desmo? You're probably just following along and watching. Is that true?
Yeah.
Okay, Katie downloaded an app. Nice job, Katie. So, so it wouldn't be a bad idea if you want to do that. Otherwise, I mean, you'll get a calculator sooner rather than later. But you could also use Desmos if you want to. And Miriam downloaded the app.
Desmos isn't doing that good, so I think I might have to change my mind and pick up a calculator.
You're not feeling that Desmos is not doing very well today, huh, Youngson?
Yeah.
Okay. So we have the parent graph, y equals x squared. Let's see if we can change that equation. So I'm going to go back to y equals, and I'm going to leave my equation in there. I'm going to leave my parent graph in there, y equals x squared. I'm arrowing down. And now I'm going to give us a different parabola. I'm going to transform it a little bit. I'm going to still do x squared. But let's go minus 3 and see what happens. Okay, so we have our parent graph. Now we have y equals x squared minus 3. So I hit the graph button in the upper right. So my calculator, it's the CE, and that stands for color addition. So mine is nice enough to have multiple colors. So my original is in blue. The x squared minus 3, what did it do to it? Good. It went down 3. The x squared minus 3, that moves it down 3. Okay? If I wanted to, I'm going to change this to plus 3, and you can see probably what you expect would happen. Instead of going down 3, the plus 3 is going to move it up 3. Okay? So if we have a number added to the end of our parent equation, y equals x squared. So if x squared plus 10, it's just going to shift it up 10. If it's x squared minus 6, it's going to shift it down 6. So we're going to remember that the number after it is going to either shift it up or down. Okay, so back here, I'm going to get rid of that one. Still have our parent one. Now I'm going to put something in parentheses. So x minus 4 parenthesis, and then I'm going to square that using the x squared button. So if we have x minus 4 in the parentheses squared, how's that going to impact my graph? Well, I still have my parent graph, and the x minus 4 actually moves it right 4. Now, if you thought about it, you probably were thinking the minus 4 is probably going to move it to the left, but it's the opposite. If there's a minus in the parentheses, it moves it to the right. Now, we're going to learn this year, we're going to learn about parabolas, we're going to learn about absolute values, we're going to learn about exponentials, a little bit of logs, we're going to learn about cubic, we're going to learn about lots of different types of functions. If you understand what we do with parabolas, that's going to carry over very well to the other functions. It's pretty consistent. If we have an x minus 4 in parentheses for a parabola, and that shifts it right 4, that's also going to move a cubic to the right 4. A cubic is when it's to the third power, not second power. And it's going to move an exponential to the right 4. So that's going to be consistent with all types of graphs. It's going to move an absolute value to the right 4. Okay, so we could combine them, and I'm going to do x minus 4 squared, and then I'm going to do I'll do plus 2. Okay, so that x minus 4, we know it moves it right 4. The plus 2, we've already said that if we add or subtract something at the end, it's going to move it up or down. So it's all going to be about something called this vertex. A vertex of a parabola is either the highest point or the lowest point. It's like where it stops and changes direction. That vertex right there, it's hard to line up. That vertex right there is 4 to the right and up 2. And that's how we're going to graph. So you're going to graph these, you're going to make sketches on graph paper. If you're given y equals x minus 4 squared plus 2, you're going to go right 4, up 2, and you're going to put a dot. So if I was doing this without a calculator, and this is my graph paper, if I have y equals x minus 4 squared plus 2, that means we're going to move right 4 and up 2, and we're going to put a dot right there. That's the most important point on the whole parabola. Okay? That's called the locator point, or the vertex of the parabola. Okay, and then you can just draw the shape from there. Okay, the way we're doing it, we're not going to make a huge table right now. I'm not going to make. I want you to be able to find that point where the vertex is 4, 2, and then this parabola opens up, and it's just a normal shape. All right, there's a couple more things that a parabola could do. So going back to our calculator, let's put a number out in front. So if I want to keep this on my screen, but I don't want it to appear on the graph, I can move my arrow over to the equal sign, hit enter, and it toggles it off. So now when I graph it, it won't appear on the graph. But it's still there in my calculator if I ever want to graph it again. Okay, so sometimes it's useful if you have a big long equation, you're like, I think I need that still, but I don't want to look at it on the graph. You can turn it off, toggle it off, and it's still going to be there. All right, so let's do 3x squared. All right, I thought I typed it in. I'm still on the equal sign, I guess. 3x squared. So I still have the parent. Now I'm going to compare the parent graph with 3x squared. See how they compare. There's my parent graph. Okay, so it makes it skinnier. It's called a vertical stretch. If you just say skinnier, I'm okay with that. That's probably the language that I'm going to use. So if you have a number out in front of the x squared that is greater than 1, it's going to be skinnier. If it's greater than 1, it's going to be skinnier. If it's just 1, it's the normal shape. Okay? If it was less than 1, like 0.3, here comes my parent graph, and here comes y equals 0.3x squared. Okay, you can see that it is wider. It's a wider opening to the parabola. Okay, so the number out in front determines how skinny it is or how wide it is. If I asked you, how would you describe a parabola that is y equals 0.3x squared, I would say its vertex is at 0, 0, because it doesn't get moved at all. It's just a normal equation. But it would be wider because it's 0.3, which is between 0 and 1, less than 1. Okay, last thing I'm going to show you. If I had, let's say I'm going to change that decimal point, I'm trying to catch up, to negative. So let's say it's negative 3x squared. You might guess what it would look like. Here is the graph of the parent, and negative 3x squared opens down. So it's still a parabola. It still has a vertex at 0, 0. It's just skinnier, and it opens down because of the negative. Okay, so that's a lot of information. That's like a week's worth of information on parabolas. I'm going to summarize it with a general formula. You might want to write this down. So y equals a x minus h squared plus k. So we're just assigning a letter to each of these. It's the general formula for a parabola. The h comma k is the vertex. So the minus k, that determines whether it's left or right. The k, minus h is left or right. The plus k is up and down. And then this a, if a is greater than 1, it's skinny. If a is less than 1, I'll say, and greater than 0, it's wide. And if a is negative, it opens down. Okay, so I try to take decent notes as I'm going through my lessons. And at the end of the day, or at the end of the lesson, I'll just I'll scan my notes and put them on the Google Classroom anytime people want to. Usually there's at least one person in the class that say, will you put those notes online? So I will typically just put them all online. Let's do an example. So if I have y equals x squared minus 2. And I asked you to find the vertex. Find the vertex. Graph the parent. Graph the equation. Alright, so y equals x squared minus 2. My parent is just right at 0, 0, and it opens up. And that's y equals x squared. Okay, the parent never changes. The book will ask you to do the parent quite a bit. You're just going to get used to graphing y equals x squared. It seems a little bit redundant to do the same thing every time. So if I was going to graph x squared minus 2, can somebody tell me, without looking at your calculator, what does the minus 2 do? Do we remember? Good, it goes down 2. So we would go down 1, down 2, and we would draw the same shape opening up, and that's y equals x squared minus 2. So if that's what it does, this is my vertex right there. My vertex would be 0, comma, -2. It's that point right there. Okay. Why don't you do the same thing? Why don't you try this one? Let's do y equals x plus 3, that's a 3, squared. I want you to graph the parent and the equation and tell me where the vertex is. People in class here, is there graph paper back there in the corner?
Yes.
Okay, so if you don't have to pass it out, but if you, yeah, so I would recommend, for sure, it saves you time, it makes it more accurate, going to grab your choice of the graph paper in here. That way you don't have to draw the axes every time. It's accurate and more neat. So go grab some graph paper, people in here, if you want to. Alright, so graphing the parent graph is just y equals x squared. It's centered at 0, or vertex is at 0, 0, kind of looks like that. So now we're going to graph this one. So the x plus 3 means that the vertex is going to be -3, 0, because it shifts it 3 to the left. The x plus 3 shifts it 3 to the left. So my new spot, 1, 2, 3 is right here. And it still opens up. It's not skinny or wide, it's the same shape. So I try to draw it about the same width over there. So we graph the parent, we graph the equation, and our vertex is -3, comma 0, because it got shifted 3 to the left. Make sense? So far, so good? Alright, we'll try one more parabola, then we'll do an absolute value. How about y equals -4x squared plus 2. Same instructions, graph the parent, graph the new one. Now I've kind of gotten away from the calculator use. If you want to maybe draw a sketch and check it with your calculator, that's not a bad idea. A lot of what we're going to do this year is just assuming you don't need a calculator, but it's a good thing to check. See if you did it right. It says error? Alright, so my parent graph is still the same. It's y equals x squared. The vertex, this one is not shifted left or right at all because there's nothing in parentheses. But it is moving up 2. So that plus 2 is going to go up 2 and there's no left or right. So our vertex is 0, comma 2. And it's going to open, so I'm going to put a dot at 0, 2. Is this opening up or down? Down. And how do we know that, Haley? Because it's negative. Is that what you said? Yeah, because there's a negative out in front. So it's a negative. And is it skinny, wide, or regular? Well, since 4 is greater than 1, it's going to be a skinny parabola. So I'm not going to draw out the same shape. I'm going to make it obvious that it's a skinny parabola, kind of like that. Okay, so don't make it obvious to me as I grade it. It's clear if this is your drawing of it, that's clearly a skinnier parabola than the original parent graph. Okay, questions on graphing parabolas. I don't expect you to have this mastered yet. I actually introduced quite a bit of information all at once. In your assignment, they're going to talk about domain and range. You can skip that part of the question right now. We'll come back in maybe a half hour and do domain and range. So we aren't ready to move on to the assignment, but if it asks you about domain and range, we haven't learned about domain and range yet. So just skip that for now, and then later on, after you learn it, you can go back and answer those questions. Okay, so we're now going to graph a different type of a function. It's called absolute value. I believe that you will only have linear ones, which is a line, parabolic ones, with a parabola. Actually, another name for a parabola equation is a quadratic. So when it says graphing parabolas, it's actually quadratic equations. So a parabola is the shape of a quadratic equation. So you might have some lines in your assignment, not a lot. You might have some quadratics or parabolas, and you might have absolute values. So graphing absolute value. When I say functions, we haven't really learned what a function is. You can think of as function as equations right now. Our parent is y equals absolute value of x. All right, so let's have a look at that. Y equals, I'm going to get rid of all my equations. I'm going to hit clear. Okay, absolute value is under math right here. You can hit math, and you actually have to move over to number, and it's ABS. So it's under math, and then go over to number, and it's ABS. Look at all the features of this calculator. We could do the integer part, the fraction part, we could do the minimum of something, maximum, we could find the least common multiple, your greatest common divisor. Calculator, man, this would have been helpful in like 4th grade. It could have done all your work for you. Alright, so we're doing absolute value. Abs. Hit enter. So my calculator, and any one that I checked out to you, will be in this format. The older TI-83s will actually have ABS parentheses. If you have those type of calculators, let me know and I can help you with that. But for us, it's probably going to have the actual absolute value signs, and I'm going to put x in there. So that's y equals absolute value of x. And if I graph it, it makes a V. Okay, so consistent with what we talked about with the parabolas, if I had, go to math, absolute value of x, and then if I wanted to do plus 5, I'm guessing we would guess that it moves it up 5, and it does. Okay, so plus 5 on the outside moves it up 5. If it was minus 3, it would move it down 3, consistent with what we just did with our parabolas. That's what I was talking about. If you understand parabolas, you're going to understand it helps you with the other types of functions. If I wanted to do minus 2 in addition to the plus 5, that minus 2 on the inside is going to move it right 2. Remember, it's the opposite. Right 2 and then up 5. So this absolute value function is going to go right 2 and up 5. So our vertex is 2, 5 on our new one. If I wanted to, I'm going to insert a negative 3 out front. A negative 3 is still going to do right 2 up 5, but it's going to go down because it's a negative 3. And you can tell that it's a little bit skinnier too because there's a number out front greater than 1. Okay, so all the same rules apply. So the general equation is ax minus h plus k, where the vertex again is h comma k, and the a determines up for positive, down for negative, skinny if a is greater than 1, wide if it's between 0 and 1. Alright, I have talked for 29 plus minutes. I'm going to stop right there.